In the previous skill on IPv4 static routes, we took a look at host routes, routes that went to a specific address as opposed to a network. We also identified how to do a floating static route. That's a static route that has an artificially high administrative distance, so that route just sits there waiting until the primary route that's being used disappears for some reason and the other one drops in. Well, those same techniques and topics work in IPv6 as well. So what I'd like to do is set up a scenario for us where we can actually do the best of both worlds. Do a floating static route, but also have that be a floating static host route. Let's walk through a plan, and then we'll implement it and verify it together. And here's what I propose we do. Let's create a couple new loopback interfaces. One on R1, we'll create loopback 0, and one on R3, loopback 0. And for those loopbacks, let's assign each of them an IPv6 address of 2001, DB8, 6783, and for the last part, let's use 99 and with a host portion of 99. That way it'll be very visible when we see it. Now, if we have an address like that, it is possible, and there's actually some good reasons to do it, to have the same IP address reachable in different parts of the network. So if we put that same address over here as well, then R1, if it pinged that IP address, it would get a response locally. When R3 pings it, if it's local here as well, it'll also get a response. And then for other devices in the network, when they go to that address, it's going to be based on routing and which of those addresses is closest to them. And this gets us to the concept of an anycast address. It's a routable address which is reachable at more than one location. So if we have a big planet like this, if that's the Earth, and over here we have a server at a given address, and over here we have the identical content. Maybe it's a DNS server or some other type of server that has the same abilities, and we give it the same address X here and X here, then people on this side of the planet, based on routing, can go to this server, and people over here can go to this server, even though they're pointing to the same IP address. So that's an introduction to the concept of anycast. And you might ask the question, well, Geeth, what has that got to do with our topology with IPv6? Well, if we have this IP address on both of these loopbacks, R2 is not going to know how to get to either one of them unless we add some routing information. So let's go ahead and create a static host route on R2 that points to that exact 128-bit address. So if R2 needs to reach that IP address, it can go ahead and use R1 as a next hop to get there. No problem, static host route. But what I'd like to do is let's do an administrative distance on this path of 5. And as a reminder, administrative distance, if there's two equal routes, the one that has a lower, like golf, a lower is better administrative distance, that's the one that's going to be used. And the other one, if we created a second route that pointed to R3 to get to that IP address, and we gave it an administrative distance of 6, that becomes a floating static route. So R2 would always go this direction to get to this IP address, unless something happened to this interface or there's a problem, at which point it would then go ahead and use the route that had the administrative distance of 6. I think it would be really a great exercise for us is let's create the two loopbacks on R1 and R3. We've done that before with IPv4. We'll do it again here. We'll assign this 128-bit address to each of those loopbacks respectively, and then we'll create two static host routes on R2. One with an administrative distance of 5 going the direction of R1, and one with an administrative distance of 6, a worse administrative distance, that goes over to R3. And that way R1, that resource would be used all the time unless there was a problem with this path. So with that plan in place, and I'll leave this here so we can come back to it if we need it, let's implement the loopbacks, the static routes, and then let's test it. So we're going to log into the virtual lab environment to our administration machine, which is DCNUG. And in the upper left-hand corner, we have our terminal emulator. So we'll bring up, under servers, we'll bring up connection to R1, and also R2, and also R3. And then we'll start our work over on R1. Let's create our loopback interfaces. So here on R1, we'll type in config t, and we'll type in interface loopback, and let's specify interface loopback. You know what? Before we configure, let's do show IP interface brief, and just make sure that we don't already have. Great. So we want to take a look and see what loopbacks we already have. If we think we're bringing up or starting a new loopback interface, but we're actually overriding an existing one, that's not desirable. So we have no loopbacks at the moment, so we'll do interface loopback 0, and let's give it the IP address that we talked about, with IPv6 address, and that address is 2001:6783:99:99, and we are going to give that a 128-bit mask, and boom, it is done. In fact, I'm going to copy this because we're going to use that same IP address over on R3. Let's do that now. Let's go to R3. We'll go to configuration mode, interface loopback 0, and we'll go ahead and I'm going to right click to paste, and there we go. So if R3 tried to ping that address, do a ping to its own loopback interface address, that would work. And if we did the same thing on R1, that would work. They'd be going to their local loopbacks. But if we go to R2 and we do a show IPv6 route, this router, R2, has no idea about how to get to that 99 network. It's not in the routing table, and there's no default route on R2. We left it with 2 static routes, one going to the 1 network, one going to the 3 network, but no default routes. So on R2, let's create a static host route with an administrative distance of 5 that's going left-bound over to R1. I'll bring up the graphic real quick. So if we add the command IPv6 route, and we specify this exact IPv6 address with R1 as the next hop, and the administrative distance of 5, we'll have a static route, and R2 will be able to reach that network or that IP address via R1. Let's go into configuration mode and IPv6 route, and with the route we are going to add, I'm copy pasting it. I'm going over here to R1. He's got it right there. I'm just going to go ahead and grab the whole thing. Perfect. And then we'll go back to R2, right click to paste it in, and then the next hop is going to be R1's address, which I have over here as well. So if we, on R1, if we do a show IPv6 interface brief, this will help us with some typos as well by avoiding them. And the interface that we want to use on R1 is this bad boy right there. So I'll copy that, go back to R2, paste. Oh, I fudged it. Okay, so I'm going to hit the up arrow key because I want to add the administrative distance, right, of 5. The default would be 1, so I'm going to add 5, the administrative distance, press enter, and now we have a route. So if we did a ping to this IP address and pressed enter, it's reaching that over on R1. If we did a trace route over to that address, it would show us that the next hop is R1 based on that last number in the IPv6 address. Perfect. So next, let's add a second route, which will be a floating static route here on R2 by simply using an administrative distance for that route of 6 and pointing to the next hop of R3. So to do that, in fact, I'm going to cheat just a little bit because it's all right here on the screen. I'm going to take this command, paste it, but I'm going to change the next hop. So the next hop is 23.3, which is R3, and then an administrative distance of 6, and press enter. And what did I do? Oh yeah, .3. There you go. Nice, Keith. Too much dotted decimal in the brain. Colon 3. Perfect. With an administrative distance of 6. Let me make sure I got that right. Okay, IPv6 route to that IP address, and the next hop is 23:3 with the administrative distance of 6. That looks great. So now if we do a show IPv6 route and press enter, there is somewhere, there it is. There is our static route that's going to be using R1 because it has a better administrative distance. And the one that uses R3 as the next hop to get to that destination is currently a floating static route because of the higher administrative distance. So let's test it. Let's do a trace out to that IP address, and I'll just copy paste it here. And that implies that we're using R1 based on that next hop being R1 as our next hop. Fantastic. And config T, interface gig 0/0. What we're going to do right now to make sure we're all on the same sheet of music, I'm taking this gig 00 interface on R2 and I'm shutting it down. There's just no way it can get to the next hop, and that route that currently is there is going to drop out of the routing table because the next hop is not reachable. So let's test that, and we'll do a shutdown command. And now, if we hit the up arrow key a few times and do a trace route to that same IP address again, check out the next hop. The next hop is now 23:3. It's using R3 because That was the best option it had in the routing table, even though this had a higher administrative distance than the other one. The other route that we used a moment ago is no longer available because the next hop is not available. So if we do a show IPv6 route, and I'll add static on here, there's our current active static route, the floating static route, which is now in the routing table because it's the best option. So in this video and lab regarding static host routes, we did a couple things. We not only made some static host routes on R2 to get to that loopback address, but we also did some floating static routes by having a slightly higher administrative distance for the same exact route. And that way, there was a backup plan. In case the primary route went away, the floating static route drops in, is used, and the router can have forward packets based on that route in the routing table. So I encourage you to get hands-on practice every step of the way. If you're watching this on a tablet or a mobile device or what have you, when you get time, take a few minutes and walk through and practice these labs. And the very first few times you're working with IPv6, it's not as comfortable. I have to admit, it's just not as comfortable because we're used to IPv4 and the commands may be slightly longer. But the more we practice with it, the better we're going to be with it and the more comfortable we're going to be with the interface on the Cisco router. So thanks for joining me, and I'll see you in the next nugget. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.